take a look at this chart on the slide. The first column has the chemical formula for 5 substances. Capital N lowercase a subscript 2, capital S capital O subscript 4, or sodium sulfate. The next row has capital N capital H subscript 3, or ammonia. The next row has capital A lowercase r, or argon. The next row has capital C lowercase u, capital C lowercase l subscript 2, or copper 2 chloride. And the last row has capital C subscript 6, capital H subscript 12, capital O subscript 6, or glucose. The next 3 columns are blank, and the headings state substance name, type of fundamental particle, and the last column is number of particles in a mole. I've already stated the names of these substances. What I want you to do is determine what the type of fundamental particle for each substance is. It will be either an atom, a molecule, or a formula unit. And I want you to figure out the number of these particles in a mole of the substance. Pause the video to do this. Let's see how you did. Sodium sulfate is an ionic compound because it is comprised of ions, sodium and sulfate. As an ionic compound, its type of fundamental particle is a formula unit, and there are 6.022 times 10 to the 23rd formula units of sodium sulfate in a mole of sodium sulfate. The next chemical is ammonia. Ammonia is comprised of 2 nonmetals, nitrogen and hydrogen, and thus is a molecular compound. Its fundamental particle is a molecule, and there are 6.022 times 10 to the 23rd molecules of ammonia in 1 mole of ammonia. The next chemical is argon. Argon is an element which exists as an atom. There isn't any subscript next to the formula. There are 6.022 times 10 to the 23rd atoms of argon in a mole of argon. The next chemical is copper 2 chloride. Since this is an ionic compound comprised of the copper 2 cation and chloride anions, the fundamental particle is a formula unit. There are 6.022 times 10 to the 23rd formula units of copper 2 chloride in 1 mole of copper 2 chloride. The last chemical listed is glucose. Glucose is made of nonmetals, carbon, hydrogen, and oxygen, and thus is a molecular compound. Its fundamental particle is a molecule, and there are 6.022 times 10 to the 23rd molecules of glucose in 1 mole of glucose. We can see from this chart that each chemical has the same number of fundamental particles in a mole.